Hello and welcome to this video where I talk about Traceroute. I'm Wolfgang Dremmel and I run the DE-CIX Academy. So if you're interested in more videos and other downloadable material, just head over to the DE-CIX website. There is plenty of stuff you can watch or read or download. Let's get started with this presentation about Traceroute. This is part of my Networking Basics series where I introduced a lot of topics regarding how the internet works. I talked about networks in general, about Ethernet, about IP, and also on the transport layer I talked about TCP and UDP. If you talk about packets and IP, and in this case ICMP, well, this is how Traceroute works. If you have not watched the ICMP video, I strongly encourage you to do so. In networking, well, let's have a step backward and let's talk about the reasons for packets. So why are packets being sent? Usually this happens because a user clicks on something and a device sends out an IP packet in response to get information, to send out an email, and so on. Otherwise, also, it can happen that a machine reacts to an event, like a door being opened, or a window or a temperature alarm is being raised. Think about network of things. In general, IP packets or any networking packets are being sent because some application on the application layer needs to send data. So, but this is different for ICMP. ICMP, the Internet Control Message Protocol, sends packets as a result of a network event. Quite often, a router sends these packets, like to report an exception or an error, like, for example, here in this case, a packet being dropped. So the router sends back an ICMP message to the sender of this dropped packet. The internet networking model works on layers. So we have the physical layer, that's the fibers. We have the link layer, that's Ethernet. We have the internet layer, that's IPv4 and IPv6. And on top of them, we have the transport layer. That's where usually TCP and UDP happen. And the internet model, the IP stack, is not as strict with their layers as the OSI stack. If you have no idea what this is, watch the introduction video of the Networking Basics series. Well, ICMP, that's what I'm talking today as an application for Traceroute, is using IP for transport, both IPv4 and IPv6, but it doesn't have anything above it. So unlike TCP or UDP, where there's an application layer above it, ICMP is the end of the network stack. But enough about ICMP. Well, let's talk about how Traceroute works. Well, you might have all have used it. Always looks the same. You type in Traceroute, a destination, and you get some long list of results. And the question is always, does Traceroute tell the truth? Does it tell all of the truth? And can you rely on it when debugging a network problem? And of course, how does it actually work? Let's have a look at IP headers, or the header of IP packets. And in this case, I just give an example using IP version 6, but it's quite the same for IP version 4. In the IP header of IP version 6, there is a hop limit field. In IPv4, it is called time to live, and it serves the same purpose. When a packet is created, the hop limit field is initialized to a value between 1 and 255. Quite often 64 or 128 is being used. And this hop limit field, or in IPv4 the time to live field, is decreased by every router forwarding the IP packet. And once it hits 0, the packet is discarded. Let me show you. So here my device creates an IP packet, initializes the hop limit field to 64, forwards it to a router, which decreases it to 63, forwards it to the next router, hop limit is decreased to 62, to the next, decreased to 61, to the next, decreased to 60, and delivered to the end device. But what happens if the hop limit actually does hit 0? So here we start in the middle of the packet traveling with a hop limit of 12, which is decreased to 11, which goes into some subnetwork where it comes out with a hop limit of 1. So this router now decreases the hop limit and it hits 0. So it must be discarded when the hop limit hits 0. The router discards the packet and creates an ICMP time exceeded packet, which is then sent back to the originator of the discarded packet with the source address of the router discarding the packet. So, how does Traceroute uses this? Well, we create a packet, an IP packet, and set the hop limit to 1, which means that the first router already discards the packet and sends back an ICMP time exceeded message. We record the reception of the message. We know who sent it because the IP address is in there. And we also record the round trip time, the time between sending the original packet and the reception of the time exceeded message. And we're doing that again with a hop limit of 2. So the next router in the network to the destination discards the packet and sends back an ICMP time exceeded message. Again, we record the round trip time. And we are doing that all the way until we have reached the destination or we have reached a certain limit of routers. So the third router here in this case, we also reports the round trip time. First question I have asked in my introduction, do I see all devices in Traceroute? This was our example network. These are all routers here. So they work on IP packets and they decrement the time to live or hop limit counter. But is that all devices in the network? There might be a whole cloud or unknown network in between two routers working on ATM or MPLS or a VPN tunnel. So any IP packet going through that non-IP network, the counter, the hop limit counter is not decreased, no ICMP time exceeded message are generated. So this non-IP network here between two routers is completely invisible to Traceroute. Next question, how reliable is the round trip time in Traceroute? Let's have a look at the map. I'm doing a Traceroute from Germany to Portugal. First stop is, of course, Frankfurt. So I'm getting a round trip time of 5 milliseconds. Then I'm going to Paris, getting a round trip time of 23 milliseconds. Next stop, Madrid, Strange, I'm getting a round trip time of 110 milliseconds. And at the end, Lisbon, I'm getting a round trip time of 54 milliseconds. And that looks good again. But why is the round trip time in Madrid so high? Let's have a look how the packets might have traveled. Traceroute, well, there are two packets. There is the packet being sent forward, and there is the ICMP time exceeded message coming back. Like I said, it's a round trip time. So both the time of the forwarding packet, forward going packet, and the time exceeded packet, the traveling back of the time exceeded packet to my device are added together. That's quite normal here in Frankfurt and in Paris. But for Madrid, for whatever reason, the ICMP packet takes a detour. It goes twice over the Atlantic. This is what some people call the scenic route of packets. So, and this is the reason here the round trip time in the Traceroute is so high. And you only see the way forward. You do not see the way the ICMP packet took. So please take these round trip times always with a grain of salt when debugging network problems. Conclusion. What did I talk about today? Talked about ICMP and Traceroute. ICMP packets are sent by network devices if an exception occurs. And Traceroute uses that to show a path of routers towards a destination. Keep in mind, there may be non-IP devices in that path which are completely invisible to Traceroute. Also, if you see names reported in your Traceroute, the name of devices are simply representations of their IP address, and they might be wrong. So please also keep the names in the Traceroute, especially if a location is given, with a grain of salt. The time value of a Traceroute, this is a round trip time, and the way back from the device might be a complete different one and might be longer than the network way to a device. And please, Traceroute is a nice debugging tool, but do not rely on it as your only debugging tool. If you download the slides of this presentation, at the end I have added some Traceroute software packets to read about. Also, I have some additional links with more material you can read. With that, thanks for listening. I'm Wolfgang Tremmel from the DE-CIX Academy. Thank you and bye-bye.